Hey there guys, and welcome back. So today is something I'm really excited to do. For a while now, Prusa has been running these contests, and I've been meaning to get started on them, and I just haven't. So this one is going to be our first one. As you can see, 7 days left, so we're starting this early enough. I should be able to get everything done and printed before then. I mean, knock on wood. But this is the contest we will be starting with. It's phone and tablet stands, etc. I'm putting these links in the description in case you want to look at all the specific information over here. You can see some judging criteria. I haven't gone back and looked at what designs have won previous contests, so I don't know exactly what to expect, in terms of what they're looking for. In terms of getting ready for this contest, I honestly just spent about 5 minutes of getting ready for the stream, thinking, first thing I did was I just took a quick glance at this, just to see. I don't necessarily want to duplicate anybody else's design, which is the reason I looked over here. And one of the things I was thinking about, and why I'm glad, where is it? There it is. Glad I looked here, is I was actually thinking about something along these lines. I don't know that I would have gone this far, but a wearable for your phone was something that I was considering, just because it's one of those things. There are a lot of desktop stands, and therefore I don't necessarily want to do another desktop stand. Like, if you scroll through here, there's a bajillion of them. That being said, yeah, I'm going to end up doing a desktop stand anyway, is what I've concluded, because my only other idea is already taken, and it's going to feel like I'm, at this point, having seen it, I'm ripping somebody off, so I'm going to avoid that one. So, again, spend about, let's get Fusion up. Spend about 5 minutes thinking about it. And what I decided is I'm going to do a rotating stand. And actually, rather than Fusion, let's go to my desktop, because I started pulling materials for this. Alright, cool. So, I should have like 100 of these ball bearings. I don't know where the rest of them are right now. This is not the original bag for them, so evidently I set these aside for some other project, and I'm not sure what I did with the rest of them. But I'm going to be taking measurements for these ball bearings, these BB pellets, or not BB pellets, but airsoft pellets rather, and an alternative for this. And all that, you may be saying, okay, that's a bunch of stuff that rolls, so what are we doing? I'm thinking about doing a turntable, a Lazy Susan basically, for the phone. So we'll be able to put the phone this way, have the mount adjustable to go this way. And I've got two different phones here. This is an old phone, this is my current phone to take measurements off of. And it will be set up so, if you're moving around, let's say the kitchen or the house, or well, not necessarily the whole house because that's not useful, but, your kitchen, or maybe you walk around your desk a bit. Maybe you're not always at your desk. Maybe you're in the workshop and you're not always at the same point in the workshop. So you can go ahead and spin it to continue facing yourself. So that's the idea. So we're making a Lazy Susan phone stand is what we're looking at. And I would like to, ideally, use the same exact base for all three of these options. The bearings, like the, what do you call it? The regular bearings, the ball bearings, and the BB bearings. I'd like to, if possible, fit all of them into the same exact base so you don't have different options for bases. And one of those things, Lazy Susan, the most simple design, will just be a shell. This is a cross section here. And then a bottom part of the shell that fits inside. And then some kind of fastening system, a nut down here, a central bolt, etc. And this part up here is the part that we'll attach the phone stand to. And again, the phone stand I would like to be swivelable, so it's one of those things. This part right here may just be some kind of vertical post, and then we may have a second actual clamp system that will hold the phone. And that clamp system, just from previous experience, I can't recall which designs I'm getting this from, so I apologize. I can't provide credit for this one, but a two-part clamp is all I'm looking at, and I like the idea of, which is why I have this rubber band, just using a rubber band to apply tension. There's other things. For example, I have a phone mount for a tripod stand that I have printed. It's not here, it's at work, but the phone mount for the tripod stand uses a screw up top, and you just ratchet down the top part of the clamp. That's one option, but I think makes it's a bit easier to go with this rubber band instead. So that gets us all caught up on what my thought process is for this design, and let's get started. Let's see, where do you start? I guess we start with the new component, and this will be the base. And let us also create a new component in here for ball bearing. Now for the ball bearings, for the BBs and the actual ball bearings that I have, this is one of those things where I don't think I'm going to bother with a cage. A lot of times you would put a cage in here to keep them equally spaced and whatnot. That seems like that might be more effort than is necessary. So I am going to, for the time being, just assume that we're going to fill up the Lazy Susan all the way around so that we don't necessarily need a cage. Yeah, obviously it doesn't run as smoothly because they're knocking against each other and whatnot, but it seems a lot simple. So the metal bearings I've got right here are 635, and let's check these airsoft pellets. It's been a very long time since I've played airsoft. I've actually got these ones. These ones have been sitting around from my brother. I need them for another project, and these are the leftover ones. So these are measuring at 5'8". So we got 5'8", 635, I believe I said was the other one. Let me double check that one. 6'3", I'll call it. So, and we will actually just make a sphere here. Sphere. 6.3. New component. Airsoft BB. Create a sphere. 5'8" is what I believe I said. And then if I come in here, I should have my 623s. These are 623s, right? I'm not going crazy. Yeah, 623s. So let's just insert that into here. Yeah, and as you can see, that's a lot larger than the where'd you get inserted into? Oh, whoops, you should not be all the way in there. There we go. So there's the comparative size. Actually, it doesn't look that much larger. Okay, yeah, it doesn't look that much larger. And actually, let me go ahead and color these so that they're a little easier to see. So we'll just do green for the airsoft BBs because they're green. Airsoft BB, and we'll go brass for the ball bearing just to make it stand out more. That did not work. Try again. Oh, it's not downloaded. Okay. Brass. Oh, and there are regular brass. It's funny how fusion works. Alright, so those are our 3 types of rollers. We got those in there. Now we need a cup shape to put the rollers in. So let's go ahead and do that. Just, whoops, that is the wrong pane. Toss that down there. And how big does this need to be is the question, because it honestly does not need to be that big. So for example, if we look at my phone really quick, actually, let me look at my phone really quick. Okay, had a text message. So popping back over to the camera, we look at my phone. It's pretty massive, this phone, especially in comparison to this phone, and there are even smaller phones in the world. So it's one of those things. This phone, if I put these 3 fingers here, it's about 3 by 3, let's say. So if we make that 3 inches, 75-ish millimeters round, and then yes, it is a good bit smaller than my phone, but at the same time, it's still functional, right? So I think that's what we're going to look at. Where rather than trying to match to any specific type of phone or trying to make it bigger, while it's obviously is smaller, it looks small. You might look at it and go, that seems undersized for that. With the bearings, it really shouldn't be a problem. So I think that's what we're looking at here. We're just going to call this 75 on the out to out. We'll toss in a 3mm wall. And thickness equals 3mm. And then we just want to center this on everything. So let's turn these guys off so that we can see the origin. Toss that there. And start extruding. Wall thickness. And then throw these walls in there. From object. And right, so this is the question. Excuse me while I take a sip of water. So for this shell, again, I want to be able to use the same shell for all 3 types, for the smallest bearing, the airsoft balls, the ball bearings, and the actual roller bearings. And in order to do that, the tallest one, which is the roller bearing, the Z's, this wall is going to have to be sorry, I just got lost in thought there, because back to when these bearings, it's occurring to me when these roller bearings go around the cage, I'm going to have to leave extra space so they don't bind up going around the corner. That's just something I thought of, and I probably should have been paying attention to, although to be fair, the center part here is going to be hollow, so it's not going to bump into much. And this is me rambling. So basically, this bottom wall cannot be taller than the smallest ball bearing, the airsoft BBs, because if it was taller than the smallest airsoft BBs, then the top of the container would be riding on the wall. So our max height here is less than the airsoft BB. So let's come back here. I'm gonna edit this. I'm gonna say airsoft dia equals, and now we have that saved. And now I can go back over here to the base, and we can try this again. So select that wall, select from the top here, and now we can do airsoft dia minus, let's say, 1mm. That's where we'll start off with. So now the airsoft BB will be taller than this part here. Now, the one problem we may run into is with these bearings, the tallest bearings. So let's go ahead and align these. And I forget if I have a sketch, or not a sketch, but yeah, I don't. Let me break this link really quick. It's a base component, so. Alright, fine, whatever. I don't care. What if I delete that? Yeah, alright. That's not going to work, so what I'm trying to do is get this up. Yeah, see, that's not going to work. What I needed to do was get a tangent construction line, plane rather, onto this bearing. So let me do this. Let me hop back over to this one, tangent plane there, and our reference plane. Where's the origin? Is there. And it doesn't necessarily matter that that's 0. It matters a little bit, but it doesn't matter enough that that's 0. Let's save that. Yeah, I know. I know, Fusion. Yeah, it's one of these things I would have preferred to just break the link, but okay. Alright, cool. We can still turn that off here. Sometimes it doesn't want to let you turn it off. So, modify, align, component, good. Click that, and flip. Okay. So now, if we look at this, basically, this top shell has to overlap this by at least a little bit. So what I'm going to do, we're going to capture position here. And it's one of those things. I can go ahead and grab this diameter, which 10 millimeters sounds correct. Yeah, I mean, it should be correct. I've used this model a million times. But I'm going to open up this guy rather than, because I don't think, yeah, see, I'm not seeing, well, I probably don't have the parameters saved in here. Yeah, I don't have the parameters saved in here explicitly. Don't save. So anyway, hopping back over here, change parameter, and roller bearing diameter. And that will be 10 millimeters. Okay. So basically, this overall height is going to have to be more than 10 millimeters if I'm thinking about this correctly. We will go ahead and see what happens here. So actually, this plane, I should move down 1. So this plane is the overlap plane. So let's go ahead and call that. Shell overlap plane. And this is the absolutely tallest the top shell should be. The top shell should not be any taller than this. So let's go ahead and sketch this, project that. And I don't know whether I projected the body or the previous sketch, so let's do this. I'm gonna use the previous sketch because we haven't modified the body at all. Turn sketch off, turn the bearing off. So that's the inside of this top shell. And then we can do wall thickness here, wall thickness, and then we're just going to do the same exact thing we did before, but in reverse. So that is not correct. Are you not on the right plane? Yeah, you are not on the right plane. Okay, try again. And rather than redefine the plane, especially at this point, because things are always wonky whenever I redefine planes, I just Control Z all that. It's one of those things. It takes 2 seconds to correct. Doink, doink, doink. Doink. And wall thickness. Cool. Alright, and we're back to where we were. So, from here, we're going to go... actually... how am I going to go about this? What I probably should do is we should probably let me see if this works. I don't know this is going to actually work, but if I do that, turn the bodies back on, turn that body off. Yeah, can I do furthest extent? No. Alright, yeah, that's not going to work. Okay. So, give me half a second, get another sip of water here. Alright, to make this easier on my life, we're gonna chill out a second. Hop over to here to the bearing. I'm going to flip this upside down. 180 to get my tangent plane on top now. And now we are going to go ahead, capture position, extrude this to object, there. Turn the bodies back on like I was talking about. And let's make a new component here. Top shell. Probably should add this in a new component too, but whoopsies. Alright, and then from there, we can, again, just reiterating exactly what we did before with the bottom shell. We're just going to grab the profiles, and we're doing this invert reverse from object, and then wall thickness. Alright, and there we go. Let's go ahead and get a cross section in here so that we can look at it and make sure we're not being silly. Okay. And the bottom body. So there we go. So we have our 1 millimeter of overlap here. We may want to increase that in the future. We probably want to increase that in the future. But let me show you the other thing I was talking about here. And we'll do that by coming down here. Can I tangent plane on a sphere? I actually never tried that before. Turn the bodies off. Turn that off. Turn that off. Alright, yeah, you cannot. So, yeah, this sphere is going to be difficult to work with. Let's see. How do I want to align this? Let's see what happens when we just hit align. Let's turn the section analysis off, turn the top shell off, and modify align that guy, and turn the sketch off to there. Yeah, I mean, it's not doing much. It's probably just aligning the center line is what I'm guessing. Actually, yeah, it definitely aligned the center line because I just saw it move. So, yeah, actually, I think that's gonna have to be what we do. So we're gonna align the center line to not the sketch, the inside here, and then we can move this, not that. Move component, ball bearing, and actually finish position. What I should do is back to ball bearing dia equals, that way we have that, and we can hop back up to base. All right, it's not in base, it's probably up here then. All right, there we go, and finish aligning this. So turn the other stuff off to get it out of our way. You are component, yes. All right, good. Ball bearing die divided by 2, and that should now be flush with that, in theory. And let's align you there. Yep, that's not going to work. Okay. The interesting thing, let me finish position here and check for interference. Okay, no interference is good, because when I aligned this with the wall, I saw it move, so I just want to double check that this isn't sitting somewhere weird. And actually, we can also check that by turning the analysis back on, and that does look like that's right there. So it looks like our alignment is correct. Now the only problem is going to be that the actually, you know what? Alright, so here's what I'm thinking. Basically, if I throw a track in here, which I don't particularly want to do. Okay, yeah, that's how we're going to go about this. Okay, so now, right now, what I'm thinking, and actually, let me back up just a second. And I know I'm jumping all around here. I apologize. But the one thing I wanted to do, and actually, components, top, no, let's align. So what I need to check, and which is the whole entire reason I started getting that guy into position. And the ball bearing was actually the wrong one to do. It should have been the airsoft BB since that's smaller. But the point being that I want to make sure that when this is completely closed, like this, capture position, that we're not going to that this stuff is bigger. So yeah, as you can see, this cannot go all the way down with this ball bearing in here, so that's good. And this, when it's all the way down, this lip is not scraping the ground. So those are the two things I was looking out for, that I was concerned about. We'll go ahead and align the airsoft BB really quick. Modify, align airsoft BB to floor. And then again, we're gonna have to, because we don't have a good plane to do this on, components, stop reverting to bodies. Airsoft BB, we're gonna go up by airsoft dia divided by 2. Okay, and there you go. So now we can see that, yeah, both of these are tall enough that they will sit inside that lip. Now, if I let's capture position. If I inspect this, I think we're probably 2 or 3 millimeters. Actually 3.4, that's good. So since the distance, actually let me remeasure this. Do the planes instead. Okay, there we go. I thought that might be wrong. So 1.6 is the distance from the bottom of this lip to the bottom of the floor here. And the reason I was curious about that is because, again, I wanted more than 1 millimeter when we're on the bearing. When we're aligned with this bearing, I wanted more than 1 millimeter. So, excuse me, you gotta sneeze. Okay, sneezing done. So, I wanted more than 1 millimeter overlap when we were here, which means that right now we can get 1.6, you know, I'll just call that 1.5. So let me, that's what we have room for. That will give us 2.5, which is close to the 3 I was hoping for. And that 3 is just kind of an arbitrary, I feel comfortable with that amount. So minus 2.5. And now we should be 0.1 off, which, yep, 0.1 off. One of those things, a little tight, but I'm expecting us never to actually need that, especially because this is, these balls are never going to let it go any further down than that. So it's one of those things. It's plenty of space. We've got 2.5, or in my opinion, it's plenty of overlap, 2.5 millimeters. And we could go with more if we really needed it. Last thing, actually, that I'm thinking about here is, it's not even the last thing. Obviously, there's going to be a lot more that I'm thinking about here. But back to in our original design, let's hop back to the camera so that I can indicate. Back to, we're going to have a captured nut in here. If we go with the 3 millimeter, my classic favorite 3 millimeter nut, that is, darn, I am actually blanking on how thick a 3 millimeter nut is. I think it's 2.5, but let me pull out the case really quick. 3 millimeter. Nut thickness. And for the other record, I don't think we need a captured, not a captured nut, a what do you call it, a lock nut. I don't think it's necessary, even though this is going to be spinning. I don't know that it's necessary to have a lock nut on this thing. So, all right, 2.3. So let's double check that we're zeroed. We're more or less zeroed. All right, 2.3. So if our floor thickness here is 3, then that only gives us 0.7. Sorry, back to fusion. If our floor thickness here is 3, that only gives us 0.7 left over after we cut this nut out. The question is do we really care? And honestly, we probably don't, because we don't necessarily need this space dead center here because the bearings are going to be around the outside. So that being the case, we can go ahead and raise up the inside by another 3 millimeters and to compensate. So let's go ahead and do that now. And back to this, really should have been its own component to begin with, so I'm just going to go ahead and hit the move to component button now. Bottom shell. And let's get that central everything set up. So let's turn the lid off, let's turn these guys off, and let's turn the section analysis off. And we will do that and call that top of floor. Top of floor. Okay, and let's start drawing. So we project this, turn the body off, make that construction lines, and let's get our hex in here. So here's our hex. This should be 5.45 for a 3 millimeter, and then we'll throw the outside diameter of that hex on there. And we want, I like to do at any rate, at least 3 millimeters wall thickness. Again, that's just me. That's it. On a nut, it's probably not necessary, but we can afford it, so I will be putting it in there. And then this will be a 3 millimeter hole here, running through the center for, whoops, that is M. Why did I do M? For the bolt that will hold everything together. And we don't have any reference lines for this guy, so I'm just going to call him horizontal. There we go. So let's get this cut. This hole will be cut through everything. Not that stuff though. There. Distance, two-sided. All. Cut. And let's make sure we're cutting both bodies. We are cutting both bodies. Good. And then we want to cut the hex out of the bottom. Turn the bodies off. There's that. And we're doing that from the bottom plane. Or from the bottom, rather. The bottom of the object. And I just said that was 2.3 millimeters. And I'm going to go ahead and do that. I don't think this is necessary. We weren't using, well, we didn't decide we were using any more 3 millimeter bolts in this project, but we may. So I'm going to go ahead and just include that as a parameter. And then because, and let's turn on the section analysis, because this is so thin right here, I'm going to go ahead and make this protrude a little bit. I think 3 millimeters is probably plenty enough. And we don't need the hex shape in there. So we go ahead and join. And let's put this back together. So we got a little bit of gap in here. That's plenty. That's good, honestly, to have a gap in there. That way it's not rubbing here. Although, again, as I keep on saying, with the bearings in there, it should never rub. So that's where we're at right there. And then I'm just going to back to its 3D printing. We will turn the section analysis off here. We'll add our offsets. 0.05 is what I use for 3D printing. That did not happen correctly. New offsets so it doesn't do that again. Minus 0.05. There we go. So now the bolt will sit in there, even if it's slightly small, undersized. Undersized is the word I was looking for. And I'm just going to go ahead and color this yellow. Yellow plastic. Matte is fine. Bottom shell. And the top shell. We'll go ahead and color. We already have green in here for the airsoft pellets, so let's go red. Red matte, 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 matte. Plastic matte. There we go. There we go. And let's go ahead and assemble as built joint. That and that. And you will revolve. Yeah, it should be revolve, right? Let us take the floor out, the bottom shell. and do that. And it's one of those things a little hard to see, but I'm pretty sure that's working correctly. And now we are done with the Lazy Susan part. No, we're not. We are not done with the Lazy Susan part. Because we need something to hold the bearings and the roller bearings. So, let's start working on those. New component. Now, for the... so the problem I was thinking about, and I think I stopped myself while I was starting to complicate it, rather explain it, is I was thinking if I did a ridge, which I wasn't going to do, but if it was too big, and this is going to be hard to show. Actually, let's do this. Let's see if this works well enough. Nope, not going to work well enough. Alright, let me grab... Camera's going to shake a little bit here as I pull this weight off of the, what you call it? So if I have a ridge that is too large, right? So ideally the ridge is big enough for a single row of bearings. You can see that. If it's a little bit too large, then as the bearings move, they end up staggering like that, which could jam them up. So for that reason, we're going to end up, what I'm going to do, because I can't do a single sunken in ridge for all three different types of bearings that we're going to be using here, I'm going to use individual pseudo cages. So let's do airsoft BB cage, and I'm calling these pseudo cages because they're not going to, top of floors where I'm going to start drawing, they're not going to hold the BBs individually. They're going to actually just be tracks that the BBs run in. So we'll go ahead and do this. And this central pillar that I put in here, this 3mm tall. Oh, sorry. You're still over on the desktop. My bad. All right. So back over here. Sorry, I got distracted because I was looking at the preview on YouTube. And I have no idea why my desk is extra dark today. I don't know if I accidentally changed the setting in the camera to make it that dark. But point being is we're here on the floor of this central pillar that I just made for the hex nut. We'll go ahead and use that as the thing that everything is centered around to hold it centered on the bottom shell. And then we'll just make an outside track that's connected. So that's going to look something like this. So this will be a wall here. So we'll make that wall thickness. That will be a wall there. Actually, that doesn't even need to be a wall there. So this is the inside of our bottom shell. So we can actually, whoops, not that. Make this a wall here. Just make one wall here. And then we will make this airsoft BB diameter plus, let's say, arbitrary number 0.1mm. So now this has a airsoft BB. Let's draw that in really quick. You can see if I tangent this, whoops, that is equals, that is not tangent. If I tangent this, you'll see we have 1mm space here, which is not enough for these BBs to clog up on, but they will run on the outside of this ring that we just installed here. And this ring will be centered via this center peg here, and we'll just toss some random spokes in to connect them. And let's do this. That. Actually, rather than using just the coincidence, we'll use the centered here. And these can just be wall thickness as well. And these guys want to be tangent to the circle. That's not going to happen. Let's back up a little bit here. I'm going to throw this light in first just to make my life easier. throw that guy in there, throw that guy in there, center it rather, and then we're going to throw our tangents in. Tangents. That actually should not be tangent on that side because that's the inside. So we're going to do that on that guy. Yeah, that should be overkill. That is correct. And that should be overkill. That is correct. That makes sense. All right, cool. So this side is tangent. That way it's past the circle here. And this side is coincidence. That's way it's the furthest extent. And then again, this is going to be wall thickness. And we should be good now. Just make that, and let's extrude it. And I'm only going to extrude these guys first because I'm going to pattern this around 3 times. This center spoke. And we will make this 3 millimeters because we should have 3 millimeters. Yeah, actually, rather than make it 3 millimeters, let's go to object. That makes more sense. That way this is always guaranteed to be at most as tall as the center hub. And we make a new body. And now we will go ahead. Actually, let's fix that because basically what's happening here is with these overlaps, we're losing a little bit. So I'm going to fix this first. Oh dear. Sorry. One of those funny things where Fusion does silly things when you misclick. I honestly do not believe that Fusion should take distances by clicking. That does not seem correct to me. That seems like a very poor way of defining distances, which is what happens there. And then, like I said, distance to object here, join, and we will circle pattern this around. This feature, there, select this as the axis. We can actually select either one, and I was just going to do 3. And it defaulted to adjust. Adjust is fine. Let's see. Green, yellow, red, purple. I could have swore I downloaded this one before. Do that. There we go. And let's hop up here to take a look. So there it is. And again, this Airsoft BB, I will go ahead and just move it over because it's not terribly important at this point where it is. Just make it look good. Okay, capture position, and let's turn it back on. So you can see these BBs will hang out around here, and again, at this moment, we're just going to fill this area up with BBs rather than create an actual cage which would hold X number of BBs around in a circle. This is much simpler, and therefore, and it's one of those things. Airsoft BBs are really cheap, relatively cheap, assuming you have them. And if you don't have them, you can use one of the other designs. So that concludes the Airsoft BB cage. We're going to do the same exact thing. Well, actually, I take it back. There's one more thing that we're going to do here. Let's get rid of the bottom shell and let's go ahead and minus 0.05 on here. And yeah, I'm going to do 0.1 to give us a little bit more slop because there's a couple reasons. One, this slop doesn't matter because it's the BBs moving and not necessarily this cage right here. This cage won't necessarily be moving. And what we want most of all is to be able to, we don't want difficulty, rather is how I should say it. We don't want a difficulty removing this cage if we want to swap to a different type of bearing. If we want to swap to a different type of bearing, this should not be a problem to remove. So I went 0.1. We could even go 0.15 to give ourselves even more slop. It's one of those things. I'm not particular at this point because all it's doing is sitting there. So now that we have that done, let's go ahead and make the ball bearing cage, which is the same exact process as the other one. Ball bearing cage. And sometimes I decide to use... Oh, was that not part of the bottom shell? Interesting. So I did not make the airsoft BB cage part of the bottom shell, which in some ways makes sense. In other ways, it probably should be. So I'm going to go ahead and drag this up here. And one of those things, our timeline is going to look a little bit silly, but I think the cages probably make more sense as part of this component, as part of the bottom shell component. Anyway, moving onwards, we bottom floor, project, okay. Turn the airsoft BB off, turn the bodies off. Throw our circles back in here. This is wall distance. This is wall distance. This distance here is the bearing, ball bearing dia, plus, and I said 0.1 last time, so we're going to stick with that one. And then we go ahead and toss, well, again, I'm going to start with the center line first. Make my life easier. Toss this guy in here. The bottom one's going to be tangent. This guy is going to be coincident. That way it's the furthest. It's going to be wall thickness. And because I clicked, let's not do that. Let's get rid of that quinkydink and let's do center on that, which is how I had it on the other one. All right, cool. So now we just, as before, drag this guy up. Boink, boink. And boink, boink. And that distance is going to be to the top of the hub. Distance to object hub. And why are we blue? Or why are we yellow, rather? I'm confused why that's defaulting to yellow. I guess because it's part of the component. Okay, I guess that makes sense. I'm just concerned that it's, for some reason, my concern was that, I think I have orange in here for plastic. Yeah, orange. We'll make it this orange. My concern was that it was joining. It was turning blue because it was joining, or turning yellow, rather, because it was joining. That was my only concern there. So we hop back in here to sketches, do what we did last time. And actually, let me hop into sketches and turn that into a construction line. Distance to object. Whoops, nope. Finish in that distance to object because we're at a different part in the timeline. To object, join and pattern. Pattern, circle a pattern. Feature, select. That guy, 3 is fine. And then turn this bottom off. Minus 0.15. And we groovy. What a time. Alright. Turn that sketch back off. Yeah, I guess we go ahead and move the bearing now. So let's grab this bearing, hop back out the base, move this bearing. Again, just make it look nice. It doesn't have to be precise at this point in time. 31.5, 0.3. I said it doesn't have to be nice, but here I am fine-tuning the position of it. And now last thing I'm going to do is I'm going to take these two cages, and it's one of these interesting things. You see how the difference is so small between these two? They're only off by like 1 millimeter, or maybe even less than 1 millimeter. Let us confirm. Change parameters. So that's 0.5. So we're off by 0.5 millimeters. This may be overkill having two different cages here for the bearings, because they're probably not going to double up, get offset. If we use the bear cage, if we only use the ball bearing cage, this airsoft BBs probably aren't going to get staggered and jammed up. Probably, I'm saying. So it may be overkill having both of these cages, but I'm going to leave them in for now. What I was going to say though is we're going to go ahead and make a rigid group out of all these guys really quick. So this include child components thing is okay, but I'm also going to have the ZZ bearing in here, cage in here. and that is actually going to need to rotate. So for that reason, it doesn't necessarily do, well, no, it really should rotate. It should rotate. So point being is that I don't particularly want to select this, just in case at some point we go forwards, backwards in the timeline, and then all of a sudden it gets confused and decides, oh wait, that's a child component, and now the ZZ bearing cage is a rigid component. Just one of those things I'm concerned about. So this is going to be 623 ZZ bearing cage. There we are. And we turn our bodies back on. We're starting out the same way as the other ones, but it's going to look at the end of the day a bit different. So we're going to go ahead, sketch on the top floor, and just in case you're curious of what's coming up here, if you looked at my turntable, my microwave turntable thing that I did before, and I showed the base of the turntable on there, that's exactly what we're doing here. We're going to make something that looks exactly like a microwave turntable base. Let's see. The wall thickness. Sorry, brain fart. Wow. Okay. And again, for this one, I'm just going to go ahead and do 3 spokes. Again, this is going to look very similar to the other ones at this point, but we are not going to put the outer ring on. That's going to be the trick. And now, what I'm going to need to do here, this is going to be construction line here, and we're going to center this here on that guy. This needs to be the thickness of the bearing, and that's going to be 4 millimeters. And we already know that the length of it is 10 millimeters with the diameter. So 4 millimeters. And this is bearing, roller bearing diameter. All right, so there's that. Let me turn this just into our wall thickness really quick to get that sized. And do that. Now, there's a couple things here. The reason I use the 623 ZZ bearing, why I have all these sitting around, and you'll see me use them in various designs, is because they use 3mm bolts, and 3mm bolts are useful. What I'm looking at here is I want to make sure that if I go to this corner, I have a little bit of clearance between the wall and this bearing. So that's why I'm drawing this stuff in. So now I know I'm giving myself a full 2 millimeters, which is more than enough, of clearance between the corners here as it spins and this wall. I don't want these corners, which is one of those things. I may be paranoid and I may be over exaggerating things, but I want those to make sure they clear. Now, the last thing that I'm thinking about here is I called this 3 millimeters right here, but if I want to continue using 3mm bolts to go through this bearing, then it's going to have to be a little bit larger. Now, it doesn't necessarily need to be larger right now, for the full length, I should say, rather. For example, we can call this right here the housing for a bolt, and again, that's 5.45 for a what do you call it, a 3mm bolt. And then I can go ahead and let's do a circle, let's say. Do that. So that's the radius. And then I can throw my extra 3 millimeters right here. That gets extra large, so probably don't want to do that. Basically, point being is that I can just throw some extra housing in here to cover up the -3. And even that looks too large to have some meat for this bolt to be sitting into. And I'm just going to, it's one of those things. Again, I like 0.3, I like 3 millimeters worth of space, but it's going to end up being whatever we can afford. I don't know if I've actually tried this one before. Yeah, okay, it doesn't like that. Yep, does not like trying to offset a offset alignment, which kind of makes sense. And this guy, so we said this was 2.M3 hex thickness. There we go. So now I've built in this captured portion for the bolt. And actually, rather than this being here, I think that was the correct one to move. Let me see. It looks like it, but I can't move it. Let's back up here. We're going to back up and do this. So I'm going to capture the bolt in here. The nut rather in here. And leave this at 3 millimeters. My alternative is, since I know that 5.45 is the width of the hex nut, is to make this 5.45 plus, another 6, let's say. Make this extra thick. Let's see what that looks like really quick. 5.45 plus 6. So our spokes then would be this large, and then I could just drop the hex nut in the center here. That's a possibility. And honestly, with where that's looking at, if you're looking here to here, it's close enough that I may just want to actually just make this 10. Yeah, you know what? This is what we're going to do. I know I'm talking through all this. That's why we're doing this live, because I'm making decisions on the fly. This isn't a tutorial necessarily. Why aren't you constrained like this? Oh, because you're not actually connected. Good. So that is how I ended up making this decision at this point. As I talked through it with myself, I said, what looks okay? What is acceptable? So rather than having the spindly 3 millimeter arm right here, spoke, I've decided that I find acceptable that we're going to have a captured nut in here, and it's going to be the same size as the bearing. Again, might be a little bit of overkill here. This may be thicker. I might decide when I get to printing it. When I get to printing it, I might decide that this is too thick, and I might change it back to the way it was. But for right now, I'm willing to give it a shot. And I'll do 2 millimeters here instead of 3. And we can call that a day. Okay, so let's get this extruded. So this, as always, as we've done a number of times before, is going to go up to here. New body. And then we're going to extrude the arm. Sketch. Extrude that up. Distance to object, right there. Now, important thing to note is that this bolt is not going to work. This nut is not going to work. So all that talking about why I said I'm going to do it this way, and as it turns out, that's not acceptable. So we are going to modify this. And we are going to modify this by, let's think. Okay, this is how we're going to do it. I'm going to toss a sketch in here, and I'm going to project this guy. And actually, hold on. Before I do that, finish sketch, I actually am going to extrude the rest of this up to modify, extrude to object. There. So I am going to go ahead and extrude that, and then I'm going to hop in here to the sketch, and I'm going to draw this one sideways, and then I'm going to draw what I need to be the full height of the wheel, or at least not even the full height. It doesn't necessarily need to be full height. It has to be at least 2 to 3 millimeters per my guidelines past the bolt hole, past the center bore of the bearing. So let's go ahead and get this all drawn up, so that I'm not so that if you're having trouble following what I'm saying, you have a visual representation. There and there. Okay. And turn the original sketch off. Look at it, and turn the bodies off so that we have a clearer view. So this is the center cage, the spoke. This is the spoke here. And I am going to have a bearing right here. So let's get this lined up. And let's turn all this into construction lines. So we said our bearing is 4 millimeters thick and has a diameter of that, which is 10 millimeters, right? So if I take the center line here, and actually I'm going to do it this way. I'm going to throw the bolt in here. So we're going to call this right here the M3 bolt that is going through the center of this bearing. That is the wrong tool. That and that. Nope. That and that. There we go. So here's where our M3 bolt is going to be. The problem is that our nut has to be captured. And again, I want at least 2 millimeters worth of capture. So I'm going to go ahead and start out with that. So there's my 2 millimeters. So that's 2 millimeters of plastic above the bolt, above this, where the bolt comes through. And honestly, that may be more than enough. I mean, we probably could, nah, I'm going to keep it at that. Basically, I don't want the nut and the bolt tearing through that plastic, which is why I'm giving an extra space above it. And then we're going to go ahead and throw a construction line back here. And again, I want 2 millimeters at least of plastic surrounding this bolt. So if we draw in everything, oh, sorry. This should be an M3 bolt. Let's go ahead and clarify that one. That's an M3 bolt. And now everything's constrained. So we're going to have a hole through it right here. So the hole is going to go up and down through here. And if we look down this way, it's going to be a hole, a square hole like this. So I'm going to take that back out because we don't need it. We have now defined all the space that we need for to capture the bolt, or capture the nut rather. I'm going to turn these guys back to regular lines to make it easier for me to extrude rather than throwing extra lines in there. And I'm just going to throw a slope in here. This slope is actually not necessary. And actually, maybe I won't. Maybe I won't throw the slope in here on second thought. Yeah, let's not. We're just going to have this box here. The box... Sorry. My aesthetics are bothering me. A square box here looks kind of ugly to me. I'd be much happier with some kind of transition between the low point to the high point. It's extra plastic, but at the end of the day, it's like 0.5 of a penny extra plastic, so it's really not that big of a deal. I just would like some transition point to make me happy between the spoke and the captured nut area. So that completes that, and let's go ahead and extrude it. Two-sided, distance to object, and here, and distance to object here. Okay, and now we're going to just go ahead and take that captured nut section all the way up, and to object would make more sense, or all. We could have done to object or all. And now we want to throw the bolt hole in. So let's go ahead and do that. We'll throw a construction plane there. Hop there. And again, this bottom part is the floor, keep in mind. So let's go ahead and bring the bottom shell back up. So as you can see, that bottom part is the floor, which means that the bottom of the bearing is going to be there. So let's draw that in. Turn the bodies back off because we don't need them. And this is diameter, roller bearing. And you see that's through the bottom, so that is incorrect. So we want that to be tangent to the floor. And I'm going to go ahead and throw a diagonal line in here to center this. That's not going to work, is it? Nope, it's not going to work. We'll throw a vertical line in here then to center up the bearing. So there's our bearing, and we can turn all this into construction lines because we don't actually need them. And then at the center of our bearing is the bearing's bore, which is 3 millimeters. And now we can go ahead and extrude that all the way through. Distance all, whoops, distance all, and flip that around, okay. All right, cool. So we're going to have, actually, rather than say we're going to have, let me just show you. Bottom shell. Let's turn the body back on, and let's change this color really quick. We got aqua still. You are aqua now. Let's modify, align that bearing's bore to that hole. All right, there we go. And obviously this is a bit more bulky than it needs to be because we're using a nut in here. I'm using a nut in here because of personal preference mostly. The fact of the matter is that there's 2 other ways we can do this. Well, yeah, there are 2 other ways. One, we can actually run plastic through the center of this. We could have like a snap-on kind of function where we run the spoke through the center of the bearing, and it is its own connector. That is definitely one way of doing it, and not a bad way at all. The other way is actually to put the bolt on the outside and run the nut, put the nut on the outside and then run the bolt through a little holder there. In that case, I would want to use a lock nut on the outside to make sure it doesn't slip off. And if you, I don't know if you can imagine that, but just imagine a button head over on this side, a bolt going through, and then a nut on there, and then capture the button head with some plastic. And you can see how, since all you're doing is capturing just the 3 millimeter shaft of the M3 bolt, you need a good bit less plastic. So those are the 2 other ways to do it. Between those 2, obviously, I think the just running plastic through the center of this guy makes more sense. It's easier to do. But this is the way I ended up doing it today. And I may come back and do an alternative design where it is a snap-in, where you snap the 623 right onto the shaft itself. But in the meantime, let's capture position, create pattern circle, just like we did all those other times. And actually, before I do that, we gotta offset these faces. We don't have to, but we should. Minus 0.05. And we should be good now. Now, the one other thing that you would want to keep in mind normally, and I'm not bothering just because I know for a fact that it's not going to be a problem. And actually, let me show you in real life and try not to spill the airsoft BBs all over the place. Alright, swap back to the camera. Sorry, I'm watching the airsoft BB get dangerously close to this edge here. Keep in mind that I already know that that hex nut is smaller than this bearing, so it's not going to be a problem. But back over here in Fusion, if this nut that we have here is larger than this bearing, then this nut is colliding with the floor right now. And since I'm not drawing the nut in, I don't know that for sure. I only know that for sure because in real life I have an M3 nut that I can compare to the bearing that we're aligning to, and I know for a fact that it is not colliding. But that is something that you should keep in mind if you're just randomly throwing nuts places, is that having it aligned in this direction, the horizontal sides, the sides that are parallel, are the way that you generally lock the nut in if you're doing it in this, if you're capturing it like this. And therefore, those are the that is the shortest measurement. The measurement between points is longer than the measurement between parallels, so you want to keep that in mind. Just a little tidbit. Regardless, let's go ahead and get this patterned through, and just quick glance to make sure that I am on the other screen, because I have way too many times forgotten to switch screens on you guys. So there's R3. And it did not like that, so let's change it from adjust to optimized. All right, it liked to optimize. Cool. So there's that, and the last thing to do is the same exact thing that we did on all the other ones. And we'll, again, because this is going to want to spin, I'm going to go all the way to minus 0.25. So this is a full 0.5 millimeter off from the diameter. Yes, it probably is going to rattle around back and forth a little bit, but that really shouldn't be that big of a deal in the design. And now the last thing that I'm realizing here with this one is that I probably should offset the bottom face a little bit so that the bottom face is set up from the bearings. So let's go ahead and do that really quick. So if we look at this right here, what I'm talking about is, you see how this bearing is exactly parallel with the bottom of this, with the bottom of the cage. That didn't matter for the other two, for the ball bearings and the airsoft BBs, because this part wasn't actually spinning. But now that this is spinning, this is going to be dragging on the ground. This cage is going to be dragging on the ground, and we don't want that. So let's go ahead and offset that by 0.5 millimeter. Should be fine. So now this cage should not drag on the ground. The bearing should be holding the cage suspended off of the ground. And that is probably going to be everything I do today. It is, I mean, it's one of those things. It seems to me that you probably shouldn't mention things outside of the video, but people do it all the time. So I will mention that just because of future viewers, it's not actually relevant to. But I will say that it is Easter at the moment that I'm recording this, and it will be dinner time soon for me, or at least time to start prepping for dinner, I should say. And so I am going to go ahead and stop here. We've got a lot done for today. I'm very happy with what we've got done. And just for the record, since you're here and looking at this, this top shell, let's go ahead and pick this guy up. Okay, so now it's not poking through there because actually, that's not good. Okay, oh, I know what I did. I probably moved everything at the same time. Anyway, the point being is that this looks like this is poking through right now only because I had the top shell slid down for the ball bearings. This top shell will be lifted up. If you're looking at this and saying, okay, something clearly looks wrong, no, this will be fine. We already, at the very beginning, established that we have enough space in here for the roller bearings to fit, which means that so long as the spokes are shorter than the roller bearings, which they are, we won't have anything sticking out. So with that little bit of add-on, again, I should get off and start prepping for dinner soon. So I hope you all are having a great and wonderful day, afternoon, or evening, wherever you're at in the world. And I will catch you next time.